Hello students, welcome to the Yupp Master Foundation program related to NTSE. Now we are going to take that getting the rank in this examination is very easy, and if you are going to practice the problems and you have to get the idea about that various types of problems which are frequently asked in the entrance examination. So, let us see previously we have taken one class that is related to classification of physical quantities and their measurements in their system of units. All right. Now, here we would like to get that system of units for the measurement of physical quantities related problems, what we are going to take that is very important. So, while you are talking about that measurement, so you have to estimate the physical properties, measurements is necessary. You have to estimate that electrical properties, magnetic properties, optical properties. You want to study about that light and its propagation, measurement is very important. If you want to check the strength of a material, mechanical properties, for the mechanical properties you need to have the measurement, it is very clear. So, measurement is a part of our daily activities, just you can see that. At the same time it has been involved in various steps, you have to choose the standard unit and it can be compared with that standard unit, just you can express that value in terms of that standard unit. Let us see that. Okay, if you have learned about that macroscopic phenomena and microscopic phenomena, I hope so in the lower classes you have been studied about that macroscopic phenomena. It is very clear if you have to go for that microscopic phenomenon, right. So, it is very clear that electron is going to be revolving in its orbit, we can identify that. Okay, this is the path, just we have to take that, it has been constructed. Right, this path has been constructed, yes, this is the nucleus. All right. So, you would like to know about that measurements of the atom regarding to its size, right, and also you can take that the radius of the orbit. This is going to be nucleus, this is going to be electron, this is electron, just you can take that. It has been revolving in its path, and while it is revolving continuously, it has to exchange the energy for the stability. All right. If you are going to get that stability of that electron, stability means how long it become stable in this path without losing energy. Generally, if any particle is going to be revolving in its orbit or in its path, after some times it loses its energy, no doubt at all, but here it was happened for this microscopic particle or not, let us check, just you can take that. This is the first orbit, this is the first orbit, this is going to be, let us assume, right, the electron is going to be excited here, yes, electron is going to be excited, or sometimes you can find out that this electron is going to be de-excited. So, and de-excitation. Excitation. you have to find out this one. So, the electron gains energy and electron loses, just it is going to be a continuous process, just you have to check through the absorption and emission spectra, all right. Okay. Now, you are going to have the look into that matter. You need to check that just you have to take this one, right. Yeah, you are going to talk about that electron is going to be excited and de-excited. Right. Okay. You can take that electron volt, yeah, you will take that energy it has been expressed in EV, it has been expressed electron volts, right. If you are going to get that 1 electron volt is equal to how many joules, that is going to be the question, but you need to know that electron volts can be used to represent the energy, all right. So, when it was required to excite or de-excite, it is the case, let us have the problem, yeah, previous NTSE problems, convert 1 electron volt into joules, right, it is going to be having that, right, you can take that, this is the question, all right. Now, you will take that, yeah, joule is the unit of energy, it is a derived unit of energy, right. While you are going to talk about that, work done, so and potential, work done and potential. In your lower classes you have been learned about that work done and potential. You have to take that Q be the charge, in order to displace that 1 coulomb charge, work is to be done, right, by applying the potential V volts. So, work done is going to be W, all right. Now, you can take that potential is equal to W by Q, all right. This is from the basic, right. So, this is the case we are having, all right. Now, our aim is going to be, right, 1 electron is there, it has to be, yeah, this is the case we are going to get that. Okay. Now, we would like to get this potential V and charge is Q and work done is going to be N. From the basic definition, amount of work is done to move the, to displace the charge, yes, Q, all right, it is very clear. Now, from this equation we can take that W is equal to VQ. In order to displace, in order to get the displacement, some work is going to be done, that is very clear. So, that electron, let us assume it is going to be excited. Now, if you are going to identify that work done, it is going to be its energy. Work done is nothing but energy. It is going to be equal to potential energy. It is going to be equal to potential energy, right. So, you have taken that 1 volt, 1 coulomb. Just you have to take that, this is very clear, this is equal to joule. Yeah, you have to take that. Yeah, therefore, 1 electron volt is equal to 1 Q into 1 V. Just you have to take that. Right, you can take that 1.6 into 10 to the power of minus 19 coulombs. Yes, into 1 volt. Just you can take that 1.6 into 10 to the power of minus 19 joules. Yeah, you have taken that 1 electron, it has been displaced, that amount of work is done, it has been expressed in terms of the joules. So, 1 coulomb charge we have taken, and you can take that potential is going to be 1 V. Now, you can take that potential energy is equal to charge into voltage, potential difference. Just you have to get this potential difference. We have to take that. This is the case we have to get. So, charge and V, potential difference is 1 volt, that is identified, we can take that. Let us see the answer. Yeah, 1.6 into 10 to the power of minus 19 joules, this is the correct answer, let us assume. So, the concept behind this work done to displace the charge, it has been expressed in terms of potential energy, it is very clear. So, electron volt is that unit which is used to represent that energy of that electron whenever it excited from lower orbit to higher, lower energy level to higher energy level, or higher energy level to lower level. Just you can take that excitation and de-excitation, that is a concept, it is useful for you, right. Yeah, here you would like to have that change of state, it is very clear. So, if you change that temperature, thermodynamic temperature is going to be playing very important role. Let us see that how it is. Just you can see, if you rise the temperature, what happened. So, there exists a conversion, that is mass is going to be converted into energy, it is very clear, you can take that. Yeah, if you are going to see that this is a solid having that mass, the atoms are going to be very close to each other. What happened, you have to identify that mass is going to be converted into energy, alright. You have to take that the form of energy, right, and it is going to be converted into the liquid, at the same time it is going to get that. Yeah, you have to see that when the temperature is changes, what happened, you have to see that, that is very important, right. You can get that vapor state and it is going to be converted into gaseous state, right. It means the different state, if you have taken that matter, it is going to possess the different states by changing the temperature, it is very clear. Now, we are going to talk about that energy, we are going to talk about that energy and its representation. Yeah, we would like to take that. Now, you can work is done here it is going to be energy, it is going to be expressed in joules or eggs, right. It is very clear, we are going to get this one, and you can get that calorie also. Just 1 gram of, if you have taken that 1 gram of sugar, does it gives that 4.2 calorie of energy, right. It is very clear. Now you can go for the problems, just see that. Yeah, convert 1 joule into, it is a previous NTSE problem which has given in the entrance examination, 1 joule into 1 erg, that is very clear. You have to get that 1 joule. Joule is the derived unit to represent the energy. Erg is also going to be derived unit to represent the energy in CJ system, that is for SI system. Just you can see that. Please take that 1 joule is equal to 1 Newton meter. Just you have to take that. We are going to write down it as a 1 Newton meter, all right. Right, it is the representation, it represents energy, all right. Energy, it is going to be work done. We have discussion regarding to this energy, how it is going to be equal to work done. Simply you can understood the topic. Work done is nothing but potential energy. You can take that kinetic energy also. You have to get this work done, that is force into displacement. Are you getting my point? Just you have to see, we have been started that joule, all right. You are going to get that conversion. If you wants to get the conversion from one system of unit to another one, but you need to know that what is the significance of this joule, what is the purpose, how it has been expressed in terms of other physical quantities. So, it has been represented as 1 joule is equal to 1 Newton meter. How it is possible? Let us see. Simply it represents energy, energy is nothing, just you have to take that, it is going to be work done. Work done by the system, it is going to be equal to its potential energy, it is very clear, it is energy, just you have to take that W is equal to force into displacement, just you have to take that. It is going to be in SI, while you are going to take that 1 joule, it is equal to, yeah, in SI system it is going to be equal to Newton meter, 1 joule is equal to, all right. Have you getting this point? Right, 1 joule is equal to 1 Newton meter, we have clearly understand that matter. Now, let us go for that conversion, it is very clear, we would like to get that conversion easily. What about the egg? Just you are going to get that egg, it is also the derived unit to represent the energy. So, you can get that egg, it is going to be 1 dyne centimeter, just you have to take this one, it is very clear. Now, its conversion is going to be related to that representation. So, you have to take that calculation and the substitutions. All right. All right, we can do, yeah, that is 1 joule is equal to 1 Newton meter. It is very clear. Again we are going to take that Newton, yeah, 1 Newton is equal to, yeah, it is used to represent that force. It represents the force, that is, you can get that mass into acceleration. Already you have been studied in the lower classes, but its representation is required for the conversion. Just you can take that 1 kg just meter per second square, and you have taken that meter. Okay, wait some time, just you can take this one. Up to this extent it is very clear, 1 Newton is equal to, and you have to substitute, that is equal to 1 kg meter per second square into meter. So, finally, we are having that 1 meter, 1 joule is equal to, please take that 1 kg meter square per second square. All right, you are going to convert into erg, it is very clear. Let us see that. So, finally, we are having that 1 kg meter square per second square, just we can take that. This is very clear. Now, you are going to take that to express that value, that is 1 kg, just you have to, while for air it is going to be CGS, while it is going to be SI, it is very clear, it is going to be SI system. You have to take that kg meter square per second square. Here you will take that gram centimeter square per second square. It is very clear. Just you have to convert into that matter. That is very clear. Otherwise, you have to take that dimensional formula and that related calculations. It takes very long time. Easily you will solve the problem. Say yes or no. You can convert joule into erg, easily you will convert kg into gram, meter into centimeter. Is it possible or not? If you know that, just 1 kg is equal to 10 power minus 3 grams, it is very clear. Within short period of time you have to do that. So, while you are having that conversion from joule to erg, you have to follow this one. All right. Now, it is very clear, you are going to get that, just you have to convert, that is 10 to the power of minus 3 grams into 10 to the power of minus 2 whole square centimeter square, just you have to take that and second square. Now, you can take that 10 power minus 3, 10 power minus 4 grams centimeter square second square. That is very clear, 10 to the power of minus 7 g. So, 10 to the power of minus 7, just you have to get that erg. In this process, just we can have that conversion, all right, easily you will get this. So, you are going to know that joule in what system does it represent energy? Erg, it is going to represent energy, but in system of units, system of units, just you have to take that. This is very clear. You have to get that conversion, easily you will get the answer, right. So, if you are going to take that 1 is equal to, just you have to take that 1 dyne centimeter, just you have to take that, it is very clear. Now, you are going to identify this conversion, you can take this one, right. Dyne is also one derived unit to represent the force and centimeter in CJ system. It is very clear, it is going to be work done. Energy, here also you have to get this work done and energy, very clear, easily we will solve the problem. Alright, let us go for another problem, let us see, yeah, which is the correct answer, you can check it, it is easy. 10 to the power of minus 7 x 1 joule, it's very clear. If you want to get that Planck's constant value, yes, you know the representation Planck's constant value h is equal to 6.625 into 10 to the power of minus 34 joule second. So, 6.625 into 10 to the power of minus 27 erg second, it is a case we can get this one. So, we are going to get this representation, easily we will find out that. Okay. Right, we would like to get this one. Yeah, this is the question which has been asked in the previous NTSE examination. Now, you can take that Newton second gram centimeter, just that expression is given, it is a expression, we can take that expression and that, yeah, n Newton second is equal to gram centimeter per second, you have to take that. Just you can check that, right. We are going to take this expression and solve that value of n, it is very clear. How you are going to have that solvation, you can see that, right. So, n Newton second is equal to gram centimeter per second, all right. Now, you are going to get this substitution and calculations easily, you know very well about this n Newton second is equal to grams centimeter second inverse. Let us assume, you know, 1 Newton is equal to 1 kg meter per second square. This is the case, we are going to have that, all right. Just you have to write down in the place. Therefore, n Newton is equal to 1 kg meter per second square into second, that is equal to gram centimeter second inverse, it is very clear. Now, you are going to get this take this one n into 10 to the power of 3 grams, 10 to the power of 5 10 to the power of 2 centimeter per second square into second is equal to gram second inverse, very clear. Now, we are going to get this n into 10 to the power of 5 grams into second. Just you have to take that, all right. Yeah, you can take that n into, yeah, if you wants to get this one, you have to look into that cancellation. All right, you have any terms which are going to have the cancellations, just you can take that. This is the case, we can do the cancellation. All right. So, you can get that one more cancellation here also. All right. Now, it is very clear n into 10 to the power of 5 is equal to 10 to the power of 5 gram. Just you have to final expression, that is very clear. From this expression, can you get the value of n? Is it clear? So, n into 10 to the power of 5 is equal to 1. So, finally, you have that n is equal to 1 by 10 to the power of 5. So, n is equal to 10 to the power of minus 5. It is very clear. From this one, you have to take that. They have been represented in their system of units, it is very clear. At the same time, you have to go for this conversion, how it has been represented 1 Newton, how it is going to be converted into kg, that is going to be gram. All right, it is very clear, you have to get this one. So, what is the value, just you can see. All right. Okay, 10 to the power of minus 5, we are having that answer, I hope so, this is the suitable answer, right. What we are having, this one. Very quickly you can solve the problem, easily you have to get that. In entrance examination, time is very important. So, within short period, just you have to take the equation and substitute, just instead of n you have to write, on both sides you have to get the calculations and also cancel the terms. How it is going to be substituted, how it is going to be. Very simple, you know, 1 kg is equal to 10 power 3 minus 3 grams, 1 meter, that is equal to 10 power minus 2 centimeter. If you know that, just you can answer the question, but meanwhile you have to know that this is very important. If you know that 1 Newton, just you have to replace this one. This is from definition, basic definition. 1 Newton is the derived unit to represent the force. This is from that force, all right, that is MA, can be represented. Okay, if you are very strong in the basic fundamentals, so it is easy to solve the problems in entrance examinations also, all right. Okay, let us have another session. Okay, if you want, just you can take that picture also, right. Let us go for this one. Okay, it is going to be well known to you. Why we are going to use this one to represent the atomic model, right. How the electrons, the symmetrical distribution of charge, you will take that, the symmetrical distribution of charges in atom, they are going to be identified, all right. So, if you are going to take that, the spherical portion, yes, you can take that r. What about that r? R is the radius of atom. we are going to take that to represent the radius of atom, we will use that angstrom units, right. So, it is very clear. We are going to microscopic phenomena, right. We are going to get this one, this is the atom. Let us assume, in order to represent that radius, yeah, you have to take this one, this is the radius. So, you can take that nucleus, yeah, you are going to take that nucleus, yes. So, R is the radius of atom. The radius of atom can be measured with the help of angstrom units, yeah, for their measurement. If you are going to take that nucleus, so radius is measured in terms of Fermi, just so you can have the magnitude, that is 1 angstrom it is equal to 10 power minus 10 meter, 10 power minus 8 centimeter, all right. Here if you wants to get that nucleus, yeah, this is the case we have to identify, yes, this is going to be small r. Small r is the radius of the nucleus. Let us assume it is going to be small as compared to the radius of radius of the atom. Now, it is very clear, r can be expressed in terms, it is going to be expressed in terms of angstrom units, yeah, it can be expressed in terms of Fermi, yes, all right. If you are going to get this nucleons cross section area, that is nucleons, this is the cross section area of the nucleus, all right, whatever that I am going to have that shaded area. It is represented in terms of Born, it is going to be represented Born area, that area is going to be represented in terms of bonds. So, in units and measurements chapter, you are all having that macroscopic world and microscopic world, that is you are having that the scope of examination questions encountered in microscopic and macroscopic phenomena, very clear. If they have given you the question, the light traveled, the light year, the distance travelled by the light, they are going to be identified, they are the phenomena of macroscopic, all right, it is very clear. So, simply you will get that 9.46 into 10 to the power of 15 meter, it is going to be very clear. You can express in terms of its units, but while you are going to know about this microscopic phenomena, this is very important to represent that concept, right. Let us go for that. Yeah, previously, yeah, one Born, it is going to be equal to, it is going to represent the cross sectional area of the nucleus. One Born is equal to area, it is going to be represented in terms of meter square. We will take that 10 to the power of minus 28 meter square we have learned, and that Fermi, it is going to be 10 to the power of minus 15 meter, it is going to be 10 to the power of minus 10 meter, all right, everything is clear. You are all going to know about this microscopic phenomena, radius of the atom, which may be having the range, that is 10 power minus 10 meter, it is going to be having that nearest value, and that radius of nucleus Fermi, it is going to be 10 power minus 15 meter, okay. If you are going to take that nucleus, inside the nucleus, radius has been constrained in terms of Fermi, it is very clear. while you are going to take that inside the nucleus, you are going to have that cross section area. It has been measured in terms of Born. 1 Born is equal to 10 to the power of minus 28 meter square. It is very clear. So, you might be having the chance to get the score, to get the one question. It is easy to answer the given question related to microscopic phenomena. Let us go for questions. Yeah, okay, it is very clear. Write the ascending order of units. Write the ascending order of units of length given below. Write the ascending order of the units of length given. That is, you can take that Fermi, yes, you will take that to represent the radius of nucleus. That is 1 Fermi is equal to 10 to the power of minus 15 meter. All right. Now, 1 micron, it is going to get that the thickness of that small microscopic organism, and that size 10 power minus 6 meter. 1 angstrom, already we have discussed that, yes, it is very clear. 1 nanometer, that is 10 to the power of minus 9 meter. Just their ascending order, you are going to know about that ascending order. That is, yeah, if you are going to take that, this is 10 power minus 15, this is 10 power minus 6, this is 10 power minus 10, 10 power minus 9 meter, just you have to take that. We have taken one, very clear. What are the options? Just you have to see. The first one is going to be it's easy for you, just you have to take that value, while you are going to take that 1 by 10 power 6, 1 by 10 power 9, 1 by 10 power 10, 1 by 10 power 15. That is that value, we are going to get this one, I hope so. So, if you are identifying that, which is going to be having that ascending order, just you can check the value. Yeah, among all these things, just you can check these values, right. The first one is going to be, which is, yeah, this is 1 by 15, right. Yeah, you can take this one, you can take this one, you can take this one, it is very clear. So, you will get that in this order 1, and this is for 10, yeah, this is right, okay, this is 1 by 10 power 10, just 1 by 10 power 9, just 1 by 10 power 6, we are all going to take that. So, you wants to get that this is Fermi, what we have that, okay, this is for angstrom 1 3, yeah, this is going to be 3, right, and next 9, it is going to be 4, all right, and this is going to be 2. I hope so. You have to erase some part, please erase this one. Yes, you can get this one, 1, 3, 4, 2, 1, 3, 4, 2. It is very clear. All right. Yeah, this is the correct one. Easily you will find out this one. While they are asking these type of questions, just you can take that complete value and you will get this ascending order, just that is the case. Okay students, thank you very much, have a nice day, and we would like to get that more number of classes in the coming sessions. Thank you very much.